Hello everybody, welcome to my YouTube channel. Today we are going to solve minimum number of k consecutive bit flips. The problem statement: you are given a binary array nums and an integer k. A k-bit flip is defined as a subarray chosen from nums of size k where we simultaneously change every 0 into 1 and every 1 into zeros. We are requested to return the minimum number of k-bit flips required so that there is no 0 in the array. If it is not possible, to return -1. So this is the definition of a subarray. It's a continuous part of an array. Example 1. Here k values is 1, so we can take the first element, flip it into 1, and the last element, flip it into 1. So the minimum number of k flips will be 2. But if you take the second example, it's not possible, because if you take this subarray, then we flip it into zeros, then it will have 0 zeros. But if you take the last one, we have 1 0, flip it, we'll have 0 1. So there is no way we can have all the array being 1. So to solve this problem, we can use sliding window. Since we can see, let's take this example, a sliding windows of size k, and then we'll try to flip or make sure all the zeros are flipped into 1 in each window, and then we'll slide the window, so on. So we can use data structure to achieve that. So the runtime will be of n in that case, and the space-time complexity will be of n. But there is a simpler way. You can reduce the space complexity to a constant one by using a variable. Let's call it current flip, that represents the number of flips in the current or sliding window of size k to decide either you need to perform a flipping or not. So if that variable is even and nums value is 0 at index I, we flip it. Similarly, if current flips is odd and number I is 1, we'll flip the byte. We use the parity of flip so to determine if the current window need flipping or not. And also we will mark the current byte in the array nums to be 2, and then we'll increment both current flips and a variable called total flips. That will be the answer. As the window slides, if the number at the start of the previous window I minus k is flipped, meaning it's set to 2, we decrement current flip. So, and also you have to make sure that I plus k does not exceeds the array size. Otherwise, we have to return -1, as it's not possible to mark all of the element as 1. So let's see this in this example. First of all, the windows we have 0, current is 0, so we'll set this to 2, and we'll increment, and then we'll have to increment current flip. So we increment current flip, current flips will be 1 in this case, and total flips, let's call it t, will be also 1. And then we set this value to 2. So we'll come here, this is 0 but current is 1, so you will not do anything. And this one is we're still in the first windows. So this one is 0, current is 1, so this one is even, this one is odd, this one is even, so we won't do anything. But if you come here, so this is a new window, since this will constitute the previous window, and then you have set the first element to 2. Since the first element is 2, you have flipped that array, so it will decrement current flip with -1, so on. So that's how we can solve the problem. Let's dive into the coding. We'll be using Python. We'll have current flames, total flames 0, 0. Then we'll check if I is greater than or equal to k, and grams I minus k is greater than or equal to, is equal to 2. We are checking the previous windows. If we have flipped it, we just reduce current flips by 1. If current flips mod 2 equal to num I, then we'll check. So we'll increment, we'll check first if it doesn't overflow. If k plus I plus k is greater than equal to len comes, then the current window size exceeds, so return -1. If not, we'll increment current flames 1, total flames f1, and let's set current I, the number of I, to be 2, meaning we have flipped the current window. The end, we just have to return flips. I is not defined. Oh, sorry, I have to look for I in range of number. If I is greater than len, yeah, so submit. Okay guys, thank you so much. And this is the end of the video. Please subscribe, like, share. The run complexity is O of n, the time complexity is the time complexity is O of n, and the space complexity is O of 1, or constant time. Thank you so much. Please comment, subscribe, and give suggestions. Peace out.